The story of Ethernet is best told in personal stories shared by its very own creators, providers, and users. The Voices of Ethernet archive is dedicated to preserving Ethernet's oral history, recording pivotal events that may have been forgotten or remain unknown, through a collection of spoken records with the individuals engaged in the technology's global emergence as the foundation of Internet.
Welcome back to Voices of Ethernet. Today we're talking to Rouzbeh Yassini-Fard. So Rouzbeh is a long-term friend and also a key figure in the development of the cable modem industry, which I view as sort of going hand in glove with Ethernet. So Rouzbeh, it's great to talk to you again. Could you introduce yourself to the listeners, please?
My pleasure, Peter. Thank you so much for giving me an opportunity to talk with you. I'm Rouzbeh Yassini, an Iranian-American who has been living outside the suburb of Boston since 1986. I consider myself as a serial entrepreneur who have devoted my time and knowledge to innovating, creating new technology that helps humanity and the planet Earth.
So that's a pretty broad scope. Do you want to narrow that a little bit? Because that could include developing new species of plants or potentially working on international relations.
Well, no, mainly technologies. I've been involved with the 13 plus companies. And the key innovation of my era has been what is known as a cable modem. So I'm a technologist in which I would develop boxes, systems, architectures that ubiquitously helps humanity by using the technology for the right reason and right objectives. You know.
I mean, just because I'm annoying, as you know this, right? Some of the issue with technology is you can imagine ways it's good for humanity, you can't actually enforce it. So I think this is a place where we can consider what we build and we can offer guidance. Unfortunately, we're not in the position to actually make sure stuff gets used well. And I think that's always a bit of a problem. You have to look ahead and go, what are the likely uses? All right, so going back a little bit. So as disclaimer for all of those watching, Rouzbeh and I actually worked together in a company in the first half of 1990, which is going back in date just a little bit. So Rouzbeh, do you want to tell us a little bit of a story about what that company was doing and then how that rolled through into the cable modem world?
As you know, my background comes from two elements, one from General Electric when I learned TVs and cable TVs concept, and the other one was Proteon, where I learned from concept of the networking. So those two came together and allowed me to work with the company that had the mixture of the technology where you could actually put data over coax in that nature. So that's where we actually met, Peters, if you remember.
I remember very well. It's like a formative part of my career stories.
And my goal was to be able to answer a question that I came up with in 1987. In 1987, my vision was that we had two types of a network. We had the data network, which work over twisted pair that many people can be connected in short distance. And then on the other hand, we had data that would go long distance and only few people could work on it. So I came up with the idea that why not to have a solution that voice, data, video can work for many people over long distance. And that's where my visions came together with the technology that now has been known as a cable modem. And that was the era that you and I were kind of working together in late 1980s, early 1990s. In that concept, we were able to actually do two things: pick up the best of the standards, which was coax cable TV, which was going to many consumers. And on the other hand, pick up a standard Ethernet, which was readily available, multi-vendor standard, and could help to ease the connections and the connectivity of such a networkings, both for institution and residential.
So one of the things that springs to mind here is that when I look back, I think the key things where Ethernet has progressed, in personal opinion, is that's when it's used existing infrastructure. I need you to build an entirely new cable plan is hard. And I think that the twisted pair succeeded because it could use what was in the buildings already as we deregulated that. And it seems to me the whole cable modem thing was the same thing. It wasn't, you didn't invent a brand new medium. It's like, what is around that I can use? I mean, was that in your head?
That's exactly right. So you really had two great opportunities. Coax was everywhere all over America, all over the globe, every home had access to a coax where they received their entertainment. So it was already existing cable infrastructure. Bingo. Ethernet, on the other hand, was a standard data networking that everybody in corporate America was using and around the world for connecting the office environment and office automation. And my challenge was, how do I get that beautiful standard Ethernet and beautiful standard cable work together? There were many challenges. One time I listed them more than 500 plus challenges, but fundamentally, the two challenges was get the Ethernet, go a long distance of 200 miles, and get cable, which was a hostile environment for the data and very noisy, to be more friendly and be automated in a manner that the data can travel and autocorrect itself without being damaged by the hostile environment of the cable noise. So to do those two things, we had to invent a whole new protocol. This protocol, MAC layer access, which called Unilink 2, it was innovated from the bottom up, and the goal of the Unilink was to grab Ethernet packets, take them over a long distance up to 200 miles in the noisy environment of the cable infrastructures, and allow every consumer to be connected with it and intuitively be able to get them on the system and fly and running. It took us some time, but within 6 years, we were able to make exactly that dream comes true.
So if I recall my history correctly, the thing where it started was actually more of a little bit of corporate play, because I'm pretty sure I remember deploying some of this stuff in arsenals and other places. So it was not home facilities, but it was corporations or entities that had this type of infrastructure and needed to basically build the network. And that seemed to me to be, that's sort of the place where we got to pioneer a bunch of this work. Is that correct?
Well, you got a good memory, Peter. So I take my hat off to you. In fact, there was an organization in Mississippi River called Rock Island Arsenal, known as a RIA for the short. Rock Island Arsenal was a facility, an army facility, where they provide variety of the materials for the army around the world. Rock Island Arsenal was early adopter of the technology. And in fact, we have 5,000 users up and running in 1989 in that facility, thanks to the taxpayer and government of US funding this type of technology. We were able to be years ahead of everybody else by troubleshooting and making the networks to work in institutions like Rock Island Arsenal or Emory University or Vandenberg Air Force Base or a number of other facilities.
So a bunch of those places being in the military, they tend to have fairly high expectations. So it seems to me it was a great way because you could really work through the proof points and get the value and actually make the thing reliable.
That's correct. That's correct. You not also made it reliable, but we also made it scalable, and we also made it manageable. And then we were able to bring all that together to actually lower costs. Really, the credit goes to those facilities in 1988, 1989, 1990, which gave us also learning all the aberrations of that side of a large network that comes together, what it means and how we have to manage them. So I take my hat off to those guys, and we were able to learn very quickly from them. And that's why we were able to bring an $18,000 cable modem in 1990 to less than $299 by 1996, which became to be de facto a standard or basic DNA of the DOCSIS technology to go forward.
So if I'm, again, sort of thinking through this, another part, not just the technology part, but sort of the cultural part, was at the time, Ethernet management of data networks was a little fast and furious. And you had to take this into a service provider network with a very different culture. And so you mentioned management. I think the management and provisioning side was much more important for that set of people. So I'd imagine that was a really interesting sort of culture barrier to go, let's go for the fast and furious Ethernet guys, let's plug it in, to the cable people who are actually selling that service and have to make sure it works. So that culture change must have been pretty dramatic.
Yeah, I refer to it as a plug and play. What we were used to be plug and pray. You connected these boxes and you hope it works. But in order to introduce it to residential cable, which is now broadly being used around the globe, we had to convert the plug and pray technology to plug and play. And that's again where the Ethernet comes to play. Ethernet was nice standard, easy to use, easy configurable, multi-vendors product. And once we made some automation technology to work within our cable modem that deal with aberration of the coax and the cable TV environment in the residential network, we were able to build a plug and play technology.
or plug and play and manageable. So plug, play, and operate. And so just thinking this through, this sort of predates when the main carriers got into things like DSL, because, you know, cable modem was some large number of years ahead of them.
Exactly. You know, the cable modem, if you really look at it, I call the company LAN City, which means like local area network and extended citywide. So we brought the same capability
this is get the LAN from here to there.
Yeah. So but at the residential level, right? If you look at the cable industry was purely video industry. They brought 100% of the revenue from video. And then they were started focusing later on the voice. They had no idea what the power of the data could be. And what we did, we transformed them from a video industry to telecommunication industry. And if you look at Comcast's revenue in 2022, they actually brought more money from data than they brought from the video.
Which is much like this. And just on that, were the initial adopters actually home, or was it when it started out, was it first businesses trying to solve the getting a LAN across the city problem?
No, you know, once we passed the schools, universities, government institutions, facility-wide networking, Air Force bases, and those to the data, our goal from 1991 was to work on residential stuff. We went to Stowe, which is a small town in Massachusetts. We went to San Francisco. We went to a number of small cable operators because the big cable operators were not going to take the challenge. And we did a lot of great work with a lot of small cable companies like Alabama Cables, you know, and so on.
So this is the ones who say, this is a great idea, I'm willing to try this.
Absolutely, absolutely. So the barrier to enter with a small cable operator was a lot easier. Also, at that time, if you recall, Peter, we had a lot more small cable operators around the country before the Big Ten tried to buy everybody and move forward. But all said and done, we really were 13 employees, if you will, originally that we put our minds together, the 6 advisors and myself, total 20 people who created these massive innovations on technology called cable modem, and now well over 1 million people working on broadband industry, and everybody taking the fruit of that. In a sense, if you look at COVID in 2020, if we didn't have the broadband as reliable, as manageable, as easy as we use, the entire world would have been in different trouble.
I think there's 2 questions I sort of want to go, and I think they're in parallel. And firstly is about the development of DOCSIS. And then there's development of DOCSIS and cable modem sort of in parallel with Ethernet. So I see them as being very complementary things that were happening at the same time. They were independent.
So cable modems had to be created and innovated from bottom up, because the technology on Ethernet, we had to look at Ethernet's value that it had, but also how do you overcome speed of light? How do you come latency? How do you come all those good parameters? So Unilink 2 was invented from bottom up to be able to extend them.
For a second, Ethernet succeeded when it went away from shared medium, and you had one. Yeah. You had not only a shared medium, you had a really interesting shared medium.
Yes, correct. And that shared media was a blessing, right? It was a total blessing in a sense. But so in order to also create a cable modem, you had to make the RF technology to work in a way that data modulation over a cable does not impact the videos around it. So the cable industry was very worried that how much noise we're going to put in adjacent channel. So that was really thing. So what happened when you put all that together, and we had 6 years time to test it, verify it, validate it in the residential cable, that gave us all the experience we needed to know how to equalize the solution to work. When cable industry wanted to start adopting the data back in 1995, they had already learned a bad lesson. The lesson that they learned was, oh my God, every set-top box from different manufacturers, non-standard. So in fact, they learned the Ethernet lesson. The Ethernet lesson was low cost, multi-vendors, open standard is a good thing. So they said, in the case of data, guys, let's not make the same mistake that we built in set-top box. Let's adopt the value that Ethernet brought in, which was a standard. And that created the momentum for DOCSIS, where they put an RFP out that says, who can put high-speed data over a cable and who is willing to give his technology for free to be used by the industry. We were 6 years ahead of everybody else, and we put our technology right there as a baseline and DNA of the DOCSIS. Our MAC protocol Unilink was adopted, and general instruments modulation technology was adopted, and the two together brought the DOCSIS life.
So this is sort of like the whole DICS thing where, yes, they wrote Ethernet, but then the entire plan, the success was based around making that consumable, right? Because if you held it for yourself, it would be really interesting technology, but it would have been fragmented into very small pieces.
You said it lovely. And also, we put our technology available to stand out with the zero royalty, free royalty. And that was really the key. Again, another lesson learned from Ethernet. So Bob Metcalfe, perhaps to be known as not just inventor of the cable Ethernet, and not as an inventor of the multi-vendors shared media, but he needs to be known, his principle, a ripple effect to many other technology, including cable modems, where we adopted those open mindset of the standards to go where we have to go.
So can you talk a little bit more about what's driving? You mentioned this earlier about technology for the good of humans. And so when you were thinking of the cable modem, like what did you see coming? What did you think you were going to enable?
You know, if you look at my book that I published in 2003, and if you go back to my 1997 FCC presentation, and if you go back to my 1988 meeting I had offsite with my staff, I come from Middle East. I come from area that fossil fuel and oil runs the 99.9% of the world. And with that comes pollution, and with that comes wrong politics that wars run. It has always been my dream that could we do telecommuting and could we do otherwise than not using fossil fuel? And by default, that would have solved a lot of the problem that Middle East is facing and a lot of problem that population there is facing. So my dream was, would I be able to have impact? And I was lucky enough being in General Electric and then Proteon to learn the top of a core technology that brought a vision to me that my box happened to be in center of that. In fact, if you look at the study that came from a university in India, indicated that during the COVID area, the air pollution went down by 50%. 50%. Can you imagine that? Who would have
I've actually seen the pictures, the normal in the pictures in Delhi where they could actually see the horizon.
So that was my passion. My passion have always been not like other entrepreneurs to work to make money and then go build a foundation and try to distribute money. My principal motivation has always been, what can I do to contribute to the society in a way that from get-go, my technology can have a major impact? And cable modem happened to be a right spot at the right time.
So technology is a lever. How can you enable other people to do more?
Exactly. Thanks you for simplifying it that well.
Actually, so just on a sideline, again, I recall an interesting story from you because obviously we were both a little younger at the time. And if I remember correctly, you were coming back from Germany at one stage with a whole bunch of stuff in your back pocket. And the unfortunate result of where you came from and everything you were carrying produced a little bit of a challenge. You just want to walk through that for a second?
Sure. That was 1983. I was working in General Electric. And in GE, we were developing ITT digital TV chipsets. And I had to run to Consumer Electronics Show, CES, to show the digital TV works. And we had worked so hard around the clock to get, there was only 2 working chips that ITT, 2 out of the lot of 100 that could work. And I happened to have those 2 chips to take it to CES. So I left to Germany, Freiburgers, and then to Frankfurt and tried to come in New York. The gentleman in custom was asking me, what are these? I told him, these are the chip. He looked at me, they don't look edible. What do you mean by chip? He had no idea what the chip was. So they hold me there for 9 hours, and I missed the CES show because I couldn't get there on time on opening day. And took a long time to get out of the airports with those 2 chips. Try to explain to them what they are. We had a high-level people from legal team in General Electric come in and explain to the guys that what those intention of those chip was, and things worked fine.
Because many of us have had a not quite as bad but similar experience to someone who's like, "What is that thing you're carrying, and why do you have it in your bag?" And it's like, "Well, this is complicated to explain." No,
that was I was deeply involved with the invention of the digital ITT chipsets. So it's a sidebar story, but I'm amazed you remember that story that I had shared with you. Yeah.
Well, I told you, Rouzbeh, you are one of the people I remember a lot about. So tell me how you see the future of connectivity evolving, because I would say at the minute, the bulk of what we have, right? So if I go in the not 5G world, bulk of what we have is technologies to give Ethernet to people one way or another.
Yes.
And of course, Wi-Fi is to some extent an access mechanism for Ethernet. So what do you think comes next?
Yeah, I love your question, Peter. So my vision has always been, in order to give humanity a chance to save the planet Earth that can be in a better shape to pass to our future generation, we need to obtain dynamic and live data from our waters and airs. So I imagine a day that we have all the
you can't measure, you can't manage, and you can't adjust.
Yeah. So if you get a sensor-based Ethernet hubs around the globes, that we can collect that appropriate data from the ocean and waters and from the airs, it would be a dream comes true, where high school kids and university kids and the scientists will have now real-time data to be able to see the variation of our planet Earth that will make a profound impact in the quality of life for the people. So I think Ethernet has done a fantastic job to connecting the people. Ethernet has done a great job to connecting the workforce together and the telehealth. But the next thing is, would the Ethernet be able to connect the real-time data around the air that we breathe and the water that we drink to be able to provide valuable health information to improve our quality of life? That's where I see the networking goes, and that's where I hope it goes. Perhaps not in my life cycles, but hopefully soon after. So
thinking about this, I mean, so as you well remember, Ethernet is 50 this year, and so I've been carrying around some 10-base-5 cable and some 10-base-2 stuff, showing it to people, and their first answer is, what is this?
Yeah.
I'm saying, this is Ethernet. And they say, no, that's not Ethernet. Like, let me explain. So right now, Ethernet is actually at its highest dynamic range ever, because we have concurrent standards working on 1.6T and 10 megabits, which I don't know if we had this conversation while we're doing 10 megabit, but we're going back to see the OT world.
Wow.
If I look at most buildings, right, it's going to have one IT network and a bunch of OT networks. And so I think that is the next place where we can try and take all those production control systems on. As I said, we have 1.6T really being built for the AI data center case and 10 megabit being built to connect machines together. And so I think that partly answers your question. We're on that path, because my belief is that's the next thing we can do. The Ethernet succeeded primarily through the existence of the base T cabling. Right, Cable Modem succeeded because we had that. The next thing is we actually have to run Ethernet over serial to basically deal with all the OT stuff. So that's actually my white whale at the minute.
That would be fantastic, because think about it, Peter. If for a moment we look at the planet Earth as the only planet that we know in the solar system that life can exist, if we be able to get...
You don't get to restart once you mess it up. So like a game, right? You sit in a game, you do this, you mess it up, well, I'll just start again, right? We don't have the ability to reboot it.
Yeah, so that makes perfect sense on that side. So if we can now have the low power consumption networking around the globe runs on the standards such as Ethernet, and be able to gather these valuable informations from key elements of the airs and the waters, I just fascinated with that element. To me, that is the passport for the extension of the humanity in our planet, if it can work out.
So we've done an interview with Paul Nikolic, and as it turns out, though I didn't know, Paul and you are actually sort of getting on. So where did you and Paul sort of fit together, and where do your passions align?
Well, very good. So Paul, as you know, is a major contributor to IEEE and the standardization. Thanks God we have people like him to dedicate their life to go forward. Paul and I met in 1988 in the predecessor of the Land City, which was a company called Appletech. Appletech was going down in a number of different ways because of technology that they had was not really producible in the mass way and so on. So we're not going to go to that details. But anyhow, when I interviewed the company to join them as a vice president of engineering, I wasn't smart enough to really know how bad that company was financially and how bad that company was deteriorating. I just loved the technology that they had. I said that was very good to work. Paul was working with Andy Borsa and Chris Kurbisky in that company. And he was literally left second day that I came on board. And he told me, that's no reflection on you, Rouz, but it pays basically, I don't believe this company will ever make it, and I have a family to feed. But he and I were able to have, in that short communication that we have, be such a thoughtful of each other and respecting each other that he helped me as an advisor, even though he left the company. And he was my key advisor from 1988 to 1996. I actually joined a company that he invented later called Broadband Access System as a board members. Our relationship has ever since got stronger and stronger. I consider Paul as a brother to me. We've known him since 1988. And his expertise was digital signal processing and RF. And that was instrumental for me to reshape the entire cable modem. Just give you an example. Original QPSK technology that was invented by our friend Andy Borsa had about 45 different alignments. So it would have taken one full day of two people to align one cable modem that might work in that day, because where they align it in the lab doesn't necessarily mean works in the closet or in the, somewhere that is warm or cold. So we have to take that modem, that functionality, and be able to convert it to a technology that I can build 1,000 a day without an alignment and be able to work in a hostile environment of the 45 degrees C, right? And Paul was instrumental.
So this is sort of where I describe Silicon Valley. Often people want to buy Ferraris and Formula One cars, but I'm more in the Camrys and Corollas market, right? There's a cool technology, then there's making it consumable, and they're very different.
Yeah. Yeah.
So I mentioned earlier before the interview that I spent some time with John Chapman at Cisco Live, right? And so I know John was deeply involved at the start. I just wonder if you could quickly profile where he and you fit into the creation, and really it's the productization or the making consumable the technology, right? Because as you said, there is the one that you can make work sometimes, and there's the one that works every time, and they're very different.
So the second part of my life after inventing LAN City and the cable modem that we created LAN City was join organization as executive consultant and advisors to help the DOCSIS standardization and interoperability go forward. So I created a workforce of perhaps 500 plus visiting engineers and contributing engineers from multiple vendors to help me to build this open standardization. Among them, there were 25 to 26 key people from 1996 to 1999, which were with me day in, day out as an architect, as a system engineer, as an innovator, as a think tank. All these people, John Chapman included in that, were the group that assisted us to solve and innovate and build all the hooks and the tools that we needed in our technology to have the DOCSIS to be interoperable, DOCSIS to be certified as a multi-vendors, and DOCSIS have no recall in any shape or form. So John was instrumental working, John Chapman was instrumental working with Quickly from Broadcoms, and John Ohm from my company LAN City, and a number of other people like Jerry White. These group of the 25 people were committed above and beyond the line of duty and their own company to help to make sure we can get a MAC protocol that LAN City had donated to the DOCSIS and the QAM that was donated by GI to be a better, faster, cheaper, and more interoperable. So John's name goes in history for one of those guys that he was one of the top 25 assisting and enabling DOCSIS standardization to actually work in the millions of the levels that we brought to the market.
So this, to some extent, this is taking the lessons of what Ethernet and NATO 2 did and replicating them with a somewhat different technology. It's like, I know how to make this work because I've seen it work. So I just need to basically run the same play again. Slightly different environment, but go, okay, so we've seen how this succeeds, let's go do that.
So you said it right again, Peter. And that's where I gave the name of LAN City. Ethernet created affordable LAN in corporate America that was worked ubiquitously everywhere. So when I called my company LAN City, it was exactly as you meant. And that's what DOCSIS took over, that how can you use the experience of Ethernet? How could you use the experience of the data networking and make it ubiquitous and make it to work regardless of what media is going through? And again, that's why Bob Metcalfe should get credit for building a root system that a lot of branches grow out from it. And this is one of them.
I'm assuming you saw that he received the Turing Award this year.
I did not see that, actually. Congratulations. That's
That
great.
came out a little while ago, which I think is very appropriate in Ethernet's 50th anniversary.
Yeah, it's so good to see those real things happen to real peoples, right?
Yeah, and so I think the other thing about Bob is an interesting person, but is also more than willing to recognize the contributions of everyone else involved.
Bob has been like that, yeah. Bob was a good friend, and I have met him a few times. I was in a company with him as a board member, and I learned that how he thinks, how he operates. So it's good to have those real mentors, right?
Absolutely.
And he used to live right by my house in Beacon Street in Boston before he moved to Austin, Texas. So he became to be a Texas hero. So
any final thoughts, Rouzbeh? I mean, I think particularly what would be interesting is a little bit of advice coming from the non-traditional background. Like if you're looking for people who want to follow your sort of path, what should they be thinking about? Peter, I have been from the schools of mentoring a lot of the students in university. That is my passion for many years that I have done parallel to my technical job. And I think my advice has always been to the people, find the real problem that we are facing. And based on that problem, see if you can provide a solution. Don't find a solution and then try to fit it in the problem. We have many problems that we are facing as a humanity in the world. We are facing many issues for a scale of the population we have in the world. And we have many problems that we are facing our food system, health system, and our education system. So my advice is that those problems are real, observe them, and look at them in the deep, and then use your innovation and technology and see if you can solve one of those. If we continue doing that, as Bob did with the Ethernet, I think we will go a long way, as you have done with sharing and magnifying the message that Ethernet has brought after 50 years, then we'll be fine. So I'm very hopeful and very positive to see the new generation behind us carry that flag. I just hope we can give them better than a Shark Tank and better than government-funded technology, and allow the schools and universities to flourish with that type of a thought process in a faster way. So if I paraphrase it a little bit, it's go find a problem that's real, that you really are excited about, go find a bunch of smart friends and go work. Bingo. And as you know, our development process today is a lot easier than what you and I faced back in 1990. You know, in 1990, we had to write every line of the code. We have to solve every single issue. Today, thanks to the cloud-based solution, you can almost pull universal teams together overnight. So I agree with that way to simplify it. Thanks so much. All right. So Rouzbeh, thank you so much for talking with us today, because we really appreciate hearing your background, given the place you've been in the industry and your view of it. So again, thank you very much. Thanks, Peter, for the opportunity, and good luck. So listeners, please visit the Voice of Ethernet section on the Ethernet Alliance website, because we're going to continue to document the experience of the people who were around when we built this technology, and we'd really like to get your feedback. So thank you very much, and we'll see you on the next episode.
Tune in to hear other voices of Ethernet as we continue to document the evolution of Ethernet since 1973 and explore where the technology's story might go next. Thanks for joining.